Today we're going to look at section 1.2, which is all about linear and rational equations. So today we are going to solve linear equations as well as solve rational equations. Solving linear equations in one variable. So a linear equation in one variable x is an equation that can be written in the form ax plus b equals 0. A and b are real numbers. A cannot equal 0. Solving an equation in x involves determining all values of x that result in a true statement. Such values are solutions or roots of the equation. So anytime I say what's the solution or what's the root, that means you're finding the answer that gives me every value that makes that equation a true statement. So let's solve and check this equation. We've got 4 times the quantity 2x plus 1 equals 29 plus 3 times the quantity of 2x minus 5. So our goal is to solve for x. There's variables on both sides. They're both in parentheses. I want to first distribute so I can get rid of those parentheses. So we're going to have then 8x plus 4 on the left. Bring down the 29 plus, and then I'm going to distribute the 3. So we'll have 6x minus 15. I'm going to combine like terms on the right-hand side first, 29 and negative 15. Notice that that's going to combine then into a positive 14. With variables being on both sides, I'm going to move, it doesn't matter which x you move, I'm going to move the smaller x over. So the 6x, I'm going to subtract that over to the left-hand side, which will then give me a positive 2x plus 4 equals 14. So now that x is on the left, I got to move the numbers away from x. So I'm going to subtract the 4. That gives me 2x then equaling 10. And then dividing by 2 gives me an x value of 5. So it says solve, but then it also says to check. So I would like you then to clearly show, because there's going to be times when you're not going to be able to use a calculator. And so it is going to be important that you can verify, if need be, that yes, what you got makes the left side truly equal the right side. So I'm just going to go back and substitute in the 5 wherever there was an x. And then you just have to make sure that you are very careful with order of operations. So on the left, start with parentheses. Inside parentheses, you do multiplication first. Notice that 2 times 5 is 10. Over on the right, same idea. In parentheses, you have to do the multiplication first. Okay, then I have to finish out what's in parentheses. So I have to add 10 and 1 gives me 11. So we really have 4 times 11 on the left. And then same idea inside the parentheses, 10 minus 5 is 5. So that gives me 44 on the left. Over here, hopefully this will also get me 44. Well, multiplication comes before addition, so 3 times 5 is 15. Notice that 29 plus 15 is going to get me the 44. So it checks out that I did end up getting the left side to equal the right side. So that's why x truly does equal 5. Here, to solve an equation involving fractions, we're going to find the least common denominator, or also known as the LCD, and then we'll multiply the entire equation by this. That is going to then clear the fractions. And once you clear the fractions, we're back to what we did in the last example, just solving a basic equation. So solve and then check. We have x minus 3 all over 4 equals 5/14 minus x plus 5 all over 7. So notice that we've got some fractions. Now, we didn't have to have every single term have a fraction. As long as you have more than one fraction, or technically even just one fraction, you want to look at your denominators. We want to find the least common denominator. So basically, what's the first number that all of those have in common? Notice that the biggest number is 14, so I know that it has to be at least 14, if not bigger. Okay, so if I'm looking, the fact that 7 goes into 14, but 4 doesn't, tells me that 14 isn't going to work. I need to pick the next biggest number from 14 and then see if that works. So the next factor of 14, if I double that, would be 28. Well, 4 goes into 28, and so does 7. So that tells me that 28 is that first multiple that all of those denominators have in common. So now I'm going to multiply every single thing by 28. So 28 is going to get multiplied by this entire x minus 3 divided by 4. That's going to equal 28 getting multiplied by the fraction of 5/14 minus 28 is going to get multiplied by that x plus 5 all over 7. The fact is that because 28 and 4, I'm going to divide these. 28 divided by 4 is 7, and then that gets multiplied by the numerator. Notice how I got rid of the fraction. Notice that 28 and 14 I can divide. 28 divided by 14 is 2, so then that becomes 2 times 5, because then I multiply by the numerator. Minus 28 and 7. I'm going to divide that. 28 divided by 7 is 4, and that leaves me with the numerator getting multiplied by it. So there is my clearing of the fractions. And now we're back to, can I solve for x? So once again, I got to distribute there. That gives me 7x minus 21. Over here, 2 times 5 is 10. I'm going to distribute, but notice it's not just a 4, it's a negative 4 that I'm distributing. So that turns into negative 4x minus 20. I've got some like terms to combine on the right. 10 minus 20 is going to give me a negative 10. Once again, I've got variables on both sides, so I'm going to go ahead and I'm going to move one of the variables over. I'm going to move the smaller number. So I'm going to move the 4x over, well, negative 4x over by adding it. That gives me 11x minus 21 equals negative 10. So now I'm going to add the 21 over to the other side. That still gives me 11x, and now negative 10 plus 21 is going to give me 11. And so then when I divide by 11, I get x to be 1. So then once again, the directions say not only to solve, but also to check. So I'm going to check by substituting in the 1 to every single value of x. So that gives me 1 minus 3 on the top over 4. And that equals 5/14. There's no x there, so I don't have to substitute anything in. In the numerator there, we'll have 1 plus 5 over 7. Well, notice that 1 minus 3 is negative 2, so negative 2 over 4 tells me that that's really negative a half. So that's what I'm going to try to get the right-hand side to simplify into. I can't reduce down 5/14, so that stays. Notice that 1 plus 5 is 6. And so because those denominators are not the same, I want a common denominator. So if I multiply that second fraction, both the top and the bottom by 2, that will turn that denominator into 14. So we'll have 5/14 minus 6 times 2 is 12 over 14. And now that they have the same denominator, I can combine like terms. Notice that I can subtract those numerators. 5 minus 12 is negative 7. That's still over 14. And notice that that will definitely reduce down to negative a half. So I know that x equaling 1 is correct. Had I not gotten the left side equal the right side, that meant that my x value was not correct, which meant that I made a mistake somewhere, and I'd have to go back and try to figure out how to solve for x correctly. So that's the reason for checking, is to make sure that what you got for x truly then makes the left side of the equation equal the right side. Okay, so I would suggest that you pause the video and try these 2 checkpoint problems. Make sure you're also checking your solution to know that you are correct. All right, so this is what you should have gotten for these. In the first one, you should have gotten x equal negative 1. And in the second one, you should have found first a least common denominator of 8. And notice that even though that last term of 5 didn't have a fraction, it got multiplied by 8. That's why that turned into an equation where there was a 40. So just always keep that in mind. But then we got x equals negative 20. Oops. All right, so now let's move on to rational equations. A rational equation is an equation containing one or more rational expression. To solve a rational equation, we follow the steps of an equation that involves fractions. So that means we have to find our least common denominator, but also rational expressions contain variables in the denominator. So that means our least common denominator could contain variables as well as numbers. So anytime there's a variable in your denominator, we have to make sure that the denominator will not turn into a 0, because if it turns into a 0, you're dividing by 0, and you can't do that. That turns into something that's undefined. So it's very important that we're always checking our solutions, and that's why I wanted it to do for us to do that in the last couple of examples. We want to get in the habit of checking our solutions, because now in this case, there could be answers that end up being no solution if we end up with that 0 in our denominator. So let's solve and check this. Notice that there are fractions, and notice that some of our fractions, our denominators, have some variables, and that's why these are rational equations. So we've got 3 different denominators here. We have to figure out what the least common denominator is. So if I just focus on the numbers 2, 18, and 3. 18 is the biggest. That means it has to be at least that number. Well, I can multiply 2 times something to turn into 18. And I can multiply 3 times something to turn into 18. So that means that 18 is going to be a part of that least common denominator. Now, 2 of these denominators have the same variable. So the moment you have the same variable, as long as their exponents are the same, you only need to write that variable exactly how it is. So I only have to write x 1 time. If one of the x's was x and one of them was like an x to the third, I'd have to use the bigger exponent. But in this case, if they're exactly the same, you just have to write that variable that 1 time. So now that I think I figured out the least common denominator, I'm going to multiply everything by it, and I know that I'll have the correct answer if then the fractions end up clearing away and I have no more fractions. So we're going to have 18x times that fraction of 5 over 2x. That's going to equal 18x being multiplied by 17 over 18 minus 18x getting multiplied by 1 over 3x. So once again, I'm going to divide my least common denominator by my denominator and then end up with taking that answer and multiplying it by the numerator. So 18 divided by 2 is 9. X divided by x is going to really just be 1, so there's no variable there. So really the first term is just 9 then times 5. That equals, if I take 18x and divide it by 18, well, 18 divided by 18 is 1. So then x is really getting multiplied by 17. So that turns into 17x. I'm going to bring down that subtraction sign. And now I'm going to take 18x and divide it by 3x. So 18 divided by 3 is 6. X divided by x turns to 1. 6 is getting multiplied by the numerator, which is just 1. So I know I picked the correct LCD because there are no more fractions. Now let's start solving. So 9 times 5 is 45. That still equals 17x. 6 times 1 is 6. Now I can start solving for x. I'm going to add the 6 over to the other side. That's going to give me 51 equals 17x. I'm going to divide both sides by 17, and I'm going to get a value of x to be 3. But once again, I'm not going to circle that and say that's my final answer until I check my solution. And I absolutely do not want my denominator to turn into a 0. The moment it turns into 0, I know that that can't be a solution. So luckily, the first denominator will not turn into a 0, so that's good. And then on the other side, 3 times 3 in the denominator will not turn to 0, so that's also good. So notice that we get 5/6 on the left. We still have 17 over 18 minus, now that's 1 over 9. So to combine the terms on the right, you've got to have a common denominator. 9 can get turned into 18 if I multiply the top and the bottom by 2. So now let's see if this is going to simplify down to 5/6. We are going to have 2 times 1 is 2. There's our 18. 17 minus 2 is going to give us 15. So 15 over 18, notice that those are both divisible by 3, and so that will turn into 5 over 6. So that means that x equals 3 is our solution. Let's try another one. We're going to solve and check this. Notice that we're not just dealing with monomials. Monomials don't have, addition and subtraction signs in our denominators. This time our denominators are binomials. And then we do have a monomial, okay? But the moment we see binomials, if there's something in the denominator that we could factor out, like a GCF, we want to do that first before looking for a least common denominator. And that's why we were reviewing factoring before. But x minus 2, there's nothing in common between those terms, so there's no GCF, so that denominator is going to stay as it is. Now, because two of those denominators are the exact same, just like if it was x and x, we just had to write x one time. So x minus 2 and then x minus 2, we only have to write that one time. The 3, though, also has to be a part of that common denominator because it's different from the others. So 3 times the quantity of x minus 2 is going to be my least common denominator. So that's what I'm going to have to multiply every single thing by. So it's going to take a second to write all of this out, but then hopefully we can visualize this. Where, once again, what I have being multiplied by the denominator, those are going to be divided. So x minus 2 and x minus 2 is going to divide down to 1. That's why my first term is really just going to be 3x. That's going to equal. Same thing here. The x minus 2's are going to cancel. So now we're going to have 3 times 2. Minus. Notice that this time it's the 3's that cancel. So I'm going to put that monomial first of 2 from the numerator, and then I have to keep the parentheses of x minus 2 so I don't forget and I don't lose terms there. X minus 2 is being multiplied by whatever the numerator is. Okay, that was the correct LCD because no more fractions. Now I'm going to start solving. So we'll still have 3x. That now equals 6 minus... okay, hold on. I'm going to distribute the negative 2. So make sure you distribute the negative with it. So that gives us negative 2x. Negative times a negative gives us a positive 4. I've got some like terms on the right to combine. 6 and 4 add up to 10. I'm going to add that 2x over to the other side to start combining variables. That gives us 5x equals 10. So, divide by 5. And that gives us a potential answer of x equaling 2. But remember, before I just circle it, I'm going to have to check my answer. So I'm going to go back and plug that in to any place that I see an x. So in the first fraction, we'll have a 2 on the top, and now we have 2 minus 2 on the bottom. On the second side, we'll have 2 on the top, and then 2 minus 2 on the bottom, minus 2/3. Well, if you notice, the moment one of my denominators, in this case there's 2 denominators, that's going to turn into the number 0. And remember, that's something that I can't have. So anytime I get 0, remember, I can't have this. So that's why it's super important I am not circling x equals 2. That tells us that that's not a solution. And because that was my only potential answer for x, then I would say that I have no solution. Another way to write that instead of writing no solution is using this empty set symbol. So if you just see the symbol, that indicates that I have no solution. All right, so that's why it's super important to check your work. And if you don't, you're not going to always have the correct answer. So please do that. All right, let's take a look at this example. Solve and check. So we've got 3 over x plus 2 plus 2 over x minus 1 equals 8 over x squared minus 4. Notice that our denominators are binomials. So remember, just like the last example, I first want to check to see if I can do any factoring. Well, x plus 2, there's nothing in common between those two terms. So that means that I'm not going to be able to factor out a GCF. I'm going to have that as it is. If I move on to the next denominator, x minus 2, same idea, nothing in common between an x and a 2, so that can't factor. But if I look at this third denominator, x squared minus 4, that's a difference of 2 squares because 4 is a perfect square. So this is actually going to factor into x plus 2 times x minus 2. So I can ignore that denominator and focus on this factored answer. And so now that everything's factored, it's going to help us out when we're looking for that least common denominator. So there are some similarities in all of these denominators, but that last denominator is taking the first two and multiplying them together. So that is going to be my least common denominator. So that's what I'm going to multiply every single thing by. So we're going to have x plus 2 times x minus 2 getting multiplied by that fraction of 3 over x plus 2. Plus, then we'll have x plus 2 times x minus 2 being multiplied by the fraction of 2 over x minus 2. That equals x plus 2 times x minus 2 getting multiplied by 8 over, and then I'm going to just leave it as that factored fraction or factored denominator. Okay, and so now I want to start clearing away my fractions. So notice that the x plus 2's cancel in the first term. I'm going to put the monomial first, so I'm going to put the 3 first, and that gets multiplied by x minus 2, no more fraction. Plus, notice that in the second term, it's the x minus 2's that cancel. I'm going to put that monomial first, and that turns into 2 times the quantity x plus 2. On the right-hand side, notice that that whole entire least common denominator cancels out that denominator, so it just equals 8. Once I do that, now I can start distributing, so I can start solving for x. We'll have 3x minus 6 plus 2x plus 4 equaling 8. Well, 3 and 2 is going to turn it into 5x. Negative 6 and 4 is going to turn that into negative 2. I'll add the 2. That turns into 5x, then equaling 10. Divide by 5. And so we get a value of x equaling 2. But remember, I got to check my solution. So if I go back, I've got 3 over 2 plus 2 plus 2 over 2 minus 2. And that equals 8 over, I'm going to go back to the original, and I'm going to say that it's 2 squared minus 4. So notice that while the first denominator turns into 4, the second and the third denominators, those both turn into 0, which is something that I cannot have. And since x equals 2 was my only possible solution, I cannot circle it. Once again, it's not a solution, so I'm going to say that I have no solution, or in this case, the empty set. All right, so please pause the video, see if you can solve and check. So in this case, it did end up working out. Hopefully you factored that GCF out of the first denominator, came up with your least common denominator. You were able to clear out your fractions, got x equals 2, and it worked for every denominator, and the left side equaled the right side. Okay, so that is us solving linear equations as well as solving rational equations.